GitHub Actions is a CI/CD platform. Let's first understand what CI/CD means and why it is important. CI/CD stands for Continuous Integration and Continuous Delivery, which is a widely adopted standard for software development. Most companies use the CI/CD pipeline to automate the deployment process, from running tests to building applications from source code to making releases. A continuous integration and continuous delivery platform provide automated pipelines for not just the deployment, but also running the tests, building the application from source, and making a release. This enables developers to shift software quickly and efficiently, as the majority of the release process is automated and standardized, leaving them more time to focus on fixing bugs and developing new features. So, let's finally talk about the style of this video. GitHub Action. The beta version was released in late 2019 and was quickly become preferred CI/CD tool for many open source projects hosted on GitHub. There are also many online resources available to help you learn and use it. One reason for its popularity is that it's free. As many open source projects are already hosted on GitHub, there's no need for extra signups or hooks. Another advantage is that there are many open source tools that can be easily integrated into your GitHub Actions pipeline. We will, for example, pull the code coverage into our pipeline and use it. It's straightforward and simple. I know now you can't wait to try out GitHub Action. So, if you haven't already, go ahead and sign up for a GitHub account and host your code from this course. See you in the next video. Okay, assuming you now have a GitHub account. The first thing we need to do is to create a repository to host our project. Click on the plus sign on the upper right and select View Repository, and you will end up on this page. Choose a name for the repository. I'm going to call it OS in Python. I'll put, "This is my first open source project" as the description, and make the repository public so others can contribute to it. Next, you can add a README file, a gitignore file, and a license. It's always good to have these specified, especially the README and the license, but we can add these later. Now, we have a few options to start our repository. If you have not started using Git for our project locally, follow create a new repository on the command line from the git init command. Instead of git at readme.md, you would like to use the command git at dot to add all our files instead. If you are already using Git, we will push an existing repository from the command line. Now pause the video and do that. Come back when your code is uploaded to GitHub. Now we have our code in GitHub. Let's add a README like we suggested. You can see that there's only the name of the repo and the short description. A README is used to give information about your software, how to install it, how to use it, how to contribute to it, but we are going to just leave it like this for now. Remember to go to the bottom and commit the new file. Next, to add a license, click on F file, then create a new file. Let's mean it license in all caps. And choose one from the most commonly used license template here on the right-hand side. Be sure to pick the right one for you in terms of what permission you're giving people. Check the conditions and limitations to using your softwares. I will choose the MIT license, and then I'll reveal a Savija license. You can just commit to the main branch without creating a new branch for now. Finally, to set up our GitHub action, we create a new file and name it .github, and then slash to create a new directory, and then we create another directory called workflows. Let's name our file check.yaml here. It would create a YAML file that stores the information about our GitHub action workflow. Thus, let's name the workflow. Then, we will specify when the workflow should be triggered. In our case, when there's a push and a pull request. Then, we define the jobs, which now we have only one. Here, for strategy, we specify that this job will be running on Python versions 3.8, 3.9, and 3.10. just like we did with talks. We have to set it up here because each workflow will only have one version of Python. So we have to create a job for each different versions of Python. Then we put in the actual commands for each job. Make sure we have the most updated version of pip, then install talks and run talks. Now that we have the workflow in place, let's commit this new file. After that, when you click on Actions at the top, you will see that our workflow is running. And now we have a GitHub workflow that runs our testing and linting process whenever there's a change or proposed change in our code. But this is not all. In the next video, we will learn how about code coverage and why we need it. The last topic of this course, we will talk about code coverage. Code coverage is a metric that shows the percentage of our code that is tested. It is not limited to open source projects, but it is especially important for open source projects. It is used to measure how much of our code is tested, usually represented with a percentage. There are slightly different ways of measuring code coverage, but in general, it reflects how many lines of code were successfully validated during a test. Why do we need code coverage? First of all, as an open source project, we want to show users that our code is well tested. It's also a good way for developers to check if some code or some features has not been tested. Some projects use it to safeguard their project's contributions so that when there is a pull request, tests need to be written for the new code so that the coverage percentage remains the same or increases. So, now we know we need code coverage. Let's add that to our projects in the next video. Now that we know why we need code coverage, let's add the code coverage report to our project. To make it happen, we will use a Python library called coverage that generates the code coverage report when we run the tests. To incorporate that, we need to modify our talks.int. But before we start, let's quickly get all the changes that we have made on GitHub. Now, we can edit talks.int. In the test end setting, we need to add coverage as a dependency. Then, when we run the commands, we use coverage to run the tests. We also want to report the coverage result after generating the coverage metrics. And we want to generate an XML formatted report for online reporting. Notice that we use the option omit to omit the test.py, which is the test file, which will be 100% covered no matter what. Now, save and create and run talks. Notice that now we have a report every time we run the tests. Our code coverage is less than 50%, which is very bad. Different projects will have different standards of how much coverage they required, but it's usually between 80% to 100%. That means we still have a long way to go. If we look at other files, we notice that we have a .coverage file and coverage.xml file that is generated by coverage. Let's commit and add our changes to the GitHub repo. This is nice, but what if we want to see the coverage report on our GitHub repo? No problem. We can use a web service called CodeCov. You can sign up for free with your GitHub account on codecov.io. And once you sign up, you will see your GitHub account's repositories. Pause the video and go that, and after signing up, check that your project is on the list and click on it. Since we have just started, CodeCov gives us a set of instructions on how to set up the report with your GitHub action. Pause the video and follow the first 2 steps to set up the token and the GitHub app. Stop at step 3 so that we'll do it together. Now we need to add a new job in the workflow on GitHub action. Let's edit check.yaml and add the following to the end of the file. remember to commit the changes. This is to tell the action provided by CodeCurve to use the coverage.xml that we generated for the report. Now, let's create a testing pull request to see if CodeCurve is working. Let's edit test.py and add a view test. When Retail made the changes, just create a new branch. Now, let's create a new pull request. Normally, we would put a lot more information here, but since we are only testing CodeCurve, we will create it as is. Running these tests will take a while to finish, and for CodeCurve to push the report in pull request. So, let's cut to it when it's finished. And here is the report. And we see that we have increased our code coverage from less than 50% to slightly more than 50% if we rush this pull request. Yay, a small improvement. Now, as the last homework for this course, do you think you can increase the code coverage to more than 80% by writing more tests? In the next video, we will wrap up with what we have achieved so far in this course. Congratulations to you on setting up your first open source project in Python.